Aloha and welcome to Jamba Juice 3, our third practice WOD involving JavaScript classes. Basically another simple little WOD to help you write some classes and methods and so forth. So what are we going to do? Well, we've implemented menus, menu items, and orders so far. And the problem with our representation is that it assumes that a Jamba Juice store can never run out of ingredients. So let's create a couple more classes that allow you to specify the amount of stock or inventory that a Jamba Juice store has on hand. And then when it makes a drink or tries to satisfy an order, it decreases the amount of ingredients it has available. Eventually it runs out of peach or mango or whatever, and then it can't make any more drinks. Okay? What we're going to do is we're going to have a class named inventory that holds the number of servings available for each ingredient in any Jamba Juice drink, and a couple methods on it. And then we're going to have a class called store, which holds an inventory instance, and then you can make an order, and then it will, kind of manage inventory appropriately. Okay, so that's what we're going to do. So let's start by starting our timer. And then we'll go back to JS Fiddle. It's the same JS Fiddle from last time. And we'll create a fork so that we've got a new URL that we can turn in for this WOD. And I'm going to comment out the console so that, and then let's make a new, make a console. And if we do Control Enter to run this, we see, okay, nothing happens, which is good. So we're going to create a class called inventory that holds the number of servings available for each ingredient in a Jamba Juice drink. Okay, so how are we going to do that? So we'll go to the bottom and we'll say class inventory. Now how are we going to represent our inventory? And there's a lot of different ways to do this. I'm going to show you one way. You might pick another way, and it's fine. But a convenient way in JavaScript to do it is to say, let's just have an internal variable called servings, and it's going to it's going to be an object. Okay, and the object will have keys, which is the ingredient name, like mango, blah blah blah, or peach or whatever, and the value will be the number of servings left. So it's kind of like a hash table, basically. You can think of it in other languages, except without a lot of overhead. Okay, so what else? What's the next thing we have to do here? We have to have a set inventory method, which takes an ingredient, the number of servings, and sets it. So let's write that. So set inventory, which takes an ingredient, which is a string, and the number of servings, which should be an integer, servings. And that's pretty simple to do. We can just say this dot servings ingredient equals servings. Okay, so that will update our internal data structure with a value. Let's just play around with that a little bit just to see how that works. So if I say const my inventory equals new inventory, and then I say my inventory dot set inventory mango 10, and then I'll say console.log my inventory. What happens? Okay, well, we get this inventory object, right? And it's got an internal object called servings, and this internal servings object has one element or property value pair, mango, and the value 10. Pretty cool, yeah? Okay, let's get rid of that. And go back and see what we're supposed to be doing next. Okay, so the next one is have serving ingredient. If the inventory for ingredient is greater than 0, so if we have some ingredient, then we return true and decrease the inventory for that ingredient by 1. So basically the idea is every single drink takes one serving of a particular ingredient. And so whenever we need to make a drink, we say we need one serving of mango, and we call this method. If it returns true, then that indicates we had the ingredient, we added it to our drink. If it turns false, it means we don't have, things are going to go south now because we don't have any more mango or whatever. So let's do this have serving ingredient. And the way we would write this is we could say if this dot servings ingredient is greater than 0, then we can say this dot servings ingredient double minus, which says decrement by 1, and we'll return true. Now, interestingly enough, yeah, we got to return true here, because if on our final, let's say we had 12 and we decremented to 11, and we just returned that value, this dot servings ingredient, then we'd return 11, which is actually truthy in the JavaScript world. Okay, but the problem occurs when this dot servings, the last time we have an ingredient and it decrements to 0, we'd return 0 as this value, which from a truthiness perspective is false. So we actually have to explicitly return true rather than just returning the number that's left and having its, the kind of JavaScript truthiness thing indicate the logical value. Else return false, right? Because if this dot servings is equal to or less than 0, then obviously we don't have any servings. Okay, so there's our have serving, and we could test that out. Actually, let's just have one mango, and then we could say console.log my inventory.have serving of mango, and that should return true, right? Because we have one left, and then the second one we can try. That should return false. So let's run this here. I'm going to get rid of our values here. So I'll say control. Whoops, I'm in the wrong area. Okay, so the first time we had 1. So the first time we call it, it's good. Second time return it, we don't have any left. What happens if we ask for something that is not even in our inventory, like starfruit? Let's see what happens. Okay, well, this is interesting. The first time we call it mango, we have one left, and then we call it with something that doesn't even exist in there, and we get false. And so that's pretty cool. So it means that this dot servings an ingredient that can return basically undefined, and that makes this entire expression false because undefined is not greater than 0. So JavaScript is kind of nice about dealing with certain kinds of edge cases. It kind of naturally does the right thing, or at least in this case the edge case does the right thing. Plenty of other edge cases it doesn't do the right thing. But all right, so now we've got our have servings. Okay, so create an instance and set the inventory for a few of our ingredients of our menu items. So let's just do, so we'll say we'll get rid of these guys because we don't need them anymore. And so we'll say, what should we say? We got mangoes, peach, and strawberry. Let's do that. Peach, strawberry, and let's say we got 2 servings of each of these. Okay, and then the next thing is create a class called store. A store is constructed with an inventory instance that determines whether or not it has enough ingredients to make the drink. Fine. Create a place order method that takes an order instance and attempts to fulfill it. It returns an array of all the drink instances it was able to make without running out of ingredients. And then add an accessor to the, oh, and in order to do this, we probably need an accessor called ingredients to the drink class to get its associated ingredients. Actually, we'll be cool with that. Because we can just directly access. You'll see in a second. So let's make this class called store that takes an inventory instance. Okay, so at this point that should be pretty simple. Class store, and then we have a constructor that takes an inventory instance and sets its internal value to that. So that's how we do that. And then we need a place order method that accepts an order instance and attempts to fulfill it. Okay, so place order method. And this is going to take a order. And then how are we going to do this? Okay, well, obviously we need to return the number of drinks that we're going to make. So let's start off and let's say let fill drinks equals an empty array. So that variable is going to accumulate the drinks that we were able to fulfill from our order. And then we are going to say for let drink of order dot drinks. So we're going to iterate through all of the, here's our order. We've got this property called drinks. So we can always directly access this. There's no such thing in Java as like public, private, protected like we have in Java. In JavaScript, you create a property of a particular class instance and you can just access it without any problem. Okay, so there's a convention in JavaScript that if you have an underscore in front of a property, like underscore menu item or underscore price, then the client should be respectful and not access that property directly. But it's not enforced by the language. Okay, so let drink. So we have a drink object. We're iterating through all the drink objects in our order. And now we need to try to fulfill, we need to decrement all the ingredients in this drink, or kind of call have serving and all the ingredients on this drink. And if all of those calls to have serving return true, then we've made our drink. But if any one of them returns false, then it's kaput. We haven't made our drink. So how can we do that? The way that I tend to do these kinds of things, and we'll see again in the underscore module or JavaScript 3 that there's actually some nice functional ways to do this. But here's the iterative way to do it. We could say let made drink be a Boolean that's initialized to true. And then we could say for each ingredient in the drink dot menu item, right? Every drink has an internal thing called a menu item, and every menu item has ingredients. Okay, so we can say drink.menuitem.ingredients. We can just directly access that. Okay, so for each ingredient in drink.menuitem's ingredients, if, and what we got to call this .inventory.have serving with that ingredient. And remember, this is going to return true or false, right? It's going to return true if we had enough, and it's going to return false if we ran out. So the way I would do this, I would say if it's the case that the have serving method returned false, then I'm going to say made drink equals false. Okay, indicating that that we couldn't make it. Okay, so now we come out of this for loop. We've gone through all our ingredients. We've called have serving, which is now decrementing our inventory, and we're keeping track of whether or not for any ingredient we didn't have enough servings by making this thing be false. So now we can say if made drink. So we got through that loop, and if made drink is still true, then we can say filled drinks push drink. Okay? Okay, now you might say to yourself, geez, you know, if it would be better if this barista would actually check to see they have all the ingredients they need before they make all the drink, because it seems like this barista is going to add ingredients, you know, every single ingredient, even if one is missing, and waste all those ingredients. Well, you know, this is a sloppy barista. You could think about a different algorithm which is much more sophisticated, but you know, why bother, because really we're just playing around with the class construct here. Okay, and then when we get done with all of this, we need to, here's the right one, we need to now return filled drinks. Okay, this is the the number of drinks that we're actually able to successfully make given our remaining ingredients. Okay, so there we've got that. It will return an array of all the drink instances without running out of ingredients. Okay, so to test this out, we've got our my inventory, so we can say let my store equal new store with my inventory, and now we need to create an order, and my order right now has a my drink, which is a papaya sunrise, which is papaya strawberry peach. Let's just say, just for the purposes of minimizing code. So now our inventory has 2 servings of each of the elements of a papaya sunrise. My drink is a papaya sunrise. My order has 2 papaya sunrises. So let's make 3 papaya sunrises. And so now we can say my store.place order with my order, okay, which is going to be for 3 papaya sunrises. But unfortunately, we only have enough for 2 papaya sunrises. So if we say console.log of my store, then what we should see is we get an array back with only 2 drinks in it, even though we ordered 3. So let's see if that actually happens. Let me clear this. And bam. Okay. An array of 2 drinks. First drink is a papaya sunrise. Second drink is a papaya sunrise. And we're good to go. Okay. Interestingly enough, in this representation, you use the same amount of mango regardless of whether you order a small, medium, or large. That's probably not right, right? You probably should, you know, the amount of an ingredient of servings that you use should vary with the type of drink, but who cares, right? That's just more logic. And at this point, do we care about logic? No, we don't care about logic. We're just trying to learn how to use classes. Okay, so we're going to call update to save this puppy out. There you have it, 17 minutes. We'll call it 18 minutes as Rx. So you got a little time to fool around with stuff. And that's, I hope at this point, now you've got the basic feeling of working with classes, right? You create classes, you create constructors to initialize your properties. You can access elements of these instances. We didn't get into any of the cool features of JavaScript classes, which is the fact that it's based on prototype inheritance, not classical inheritance. We're actually using this right now exactly as if it was classical inheritance. And for this very simple kind of problems that we're solving, it doesn't really matter whether it's prototype inheritance or classical inheritance or not. And in fact, in this class, I think we'll rarely get into that area. And the beauty of ES6 is that you can use the class construct to define classes in a way that if you don't really care about whether they're prototypes or not, prototype inheritance or classical, you're not having to actually deal with those mechanics the way you would have in older versions of JavaScript. So I think that's a nice feature of the modern language, is that if you don't really care about, evolving your structure at runtime, or making copies of other objects, you don't have to worry about it. All right, so that's the third WOD. Hope you enjoyed it. If you couldn't get through, or you had problems, or you DNF'd, go ahead, try it again. Just keep working through it, just typing out these constructs and writing your methods and getting errors in the console. All that stuff is really helpful. Don't view errors as a bad thing. Errors are a good thing. Errors indicate you don't understand something. Okay, it's a learning moment. All right, so don't shy away from it. And the way to be able to kind of love your errors and love the debugging is to provide yourself with enough time that you're not stressed out. So if you start these WODs early, then you'll have plenty of time. You can be relaxed. You can have the errors and not worry about it. All right. So that's my advice, and that goes for this whole course. This whole course will be so much less stressful if you just give yourself enough time to do the work. Please do that, and then at the end you will have learned so much in this semester that's truly, truly useful to you as a computer scientist. Aloha.